Hello, let's solve this problem. A shot is fired with velocity 50 meters per second from a point 25 meters in front of a vertical wall 12 meters high. Find angle of projection to enable the shot just to clear the top of the wall. G is 9.81 meters per second square. So first of all, let's visualize the situation involved in the problem. When there is height involved, height of the wall is given 12 meters high. There is ground involved. Height is always measured from ground. So this is ground where projectile is fired, that is origin. From origin at distance 25 meters there is vertical wall which is 12 meters high. So this is that situation, 25 meters in front of a vertical wall. A shot is fired. So shot is fired at point O. Find angle of projection. Magnitude of initial velocity is given. Shot is fired with velocity 50 meters per second, but angle of projection is not given. But the requirement is this shot should just clear the top of the wall. This word just is very important. It does not clear the wall with sufficient margin. It just clears the top of the wall means it almost touches the top of the wall. So this is that path. It almost touches the top of the wall. You are asked to find theta 0 so that projectile just touches the top of the wall and clears the wall. So let's follow the procedure. Choose origin where projectile motion starts. Write coordinates of points known in the path. So this point is almost in the path. So we can use coordinates of that point. If motion starts and ends at the same level, of course not. Then check whether equation of path can be used. So what is given? V0, x and y coordinates of a point in the path. And what is asked? Theta 0, and that is what I have told you. If given and asked are amongst these four variables, then we should prefer equation of path. So I am using equation of path. In that we will put V0 as 50 meters per second, theta 0 as alpha. This value is unknown right now. Then x coordinate 25 and y coordinate 12 meters. Now put the values. So y is 12, x is 25, g 9.81, v0 50, x 25. So just put the values in the formula and now you will get alpha because it is one equation with one unknown. Last step in our procedure of analysis, this I am deliberately writing this step even if it is not required in this problem because I want to print this procedure on your brain. Okay, but here equation of path is giving us answer. You just want to know alpha. But now most important thing, and all of you do these calculations yourself. When you find angle of projection using equation of path, you get two values of angle of projection. And you must get both the values. Now here that special instruction I am giving you, remember, don't use a alpha key of your calculator to find this angle alpha. One equation with one unknown. So let's use alpha key. Don't do that. Because calculator will give you only one answer if you use alpha key and type this equation as it is and get the answer for alpha. You will get only one answer. But there are two values of alpha satisfying this equation. Squared involved here. It is, if you simplify, you will realize that it is a quadratic equation and then you can use quadratic equation mode. How we proceed with the calculations? Try to understand. Just simple. It is 25 tan alpha. Calculate 9.81 into 25 squared divided by 2 divided by 50 squared. And this is how you get the equation. Then 1 by cos squared alpha is sec squared alpha. Sec squared alpha is 1 plus tan squared alpha. And now you must have realized and use these steps when you find the angle using equation of path. Now again simplify, write it in standard quadratic equation format. Ax squared plus bx plus c equal to 0. What is a? 981 divided by 800. What is b? Minus 25. And what is c? 10581 divided by 800. So ax squared plus bx plus c equal to 0. Here x means a tan alpha. So x squared means tan squared alpha. So here you will get two values of x means two values of tan alpha. Use quadratic equation mode of your calculator. This is how you have found out two values of tan alpha. And then inverse of that, you will have found out two values of alpha. Remember, when you solve a quadratic equation, you get two answers. And when it is a quadratic equation involved, if squared is involved with an unknown in an equation, then write it in proper quadratic equation format, complete the calculations, get both the values and select the correct answer. Sometimes both are correct, sometimes larger correct, sometimes smaller value is correct. It all depends on the situation involved. Now watch here, how come both answers are correct answers? Try to understand. When particle or shot is fired at an angle 28.524 degrees, then it clears the top of the wall, or it almost touches during its motion the top of the wall during its upward motion. And when it is thrown at an angle 87 degrees, very close to 90 degrees, when it is thrown at an angle 87 degrees, it almost clears again, it almost touches the top of the wall and continues to move. So this is how both answers are correct, because after all we are asked to find that angle so that projectile almost touches the top of the wall or just clears the top of the wall. So both are correct answers here. But listen, how you should select correct answer for different situation. Here I have designed the same problem, data same, but designed in this manner. A boy throws a ball from ground with velocity 50 meters per second, and it is caught by a man standing on the roof of the building. Now where this man is standing, coordinates are same, it is 25 meters from the point where ball was thrown, and he is on the roof of a building which is 12 meters high. So at what angle the ball must have been thrown, that is the question. Now of course what you will do, V0 is given, theta 0 to be found out, at what angle ball was thrown, and this man catches the ball in the sense he is in the path of the ball. So use equation of path and you will get the same two answers. But now in this case, not both answers are correct, because he is standing on roof of a building, we can see in the diagram, and ball thrown with smaller angle. Even if hypothetically this man is in that along on the path, but this ball will strike the wall here and it will not reach the man. So here ball is thrown at an angle 87.11 degrees. So here correct answer is 87.11 degrees. So same problem, but situation is little different, and the answer is 87.11. So the problem earlier we solved, both answers were correct, but here only one answer is correct, 87.11. Now watch here. Here it is basketball game going on, and this player here at origin, he wants his ball to enter into the basket. So at what angle he should throw the ball? So of course 87.11. But how will you solve the problem? Since ball enters the basket, basket is in the path of the projectile. So you will use equation of path, you will get both these answers, and the correct answer is 87.11 degrees. Read this problem. A drinking water fountain is designed such that the nozzle is located from an edge of a basin as shown in the figure. Determine maximum and minimum initial speed of the water at the nozzle so that it does not splash over the sides of the basin at P and Q. P and Q are at the same level. Now listen, when water gets ejected from the nozzle at that instant, that is initial speed is U to be found out. So V0 is U here, it is unknown. And what is theta 0? It is angle made by initial velocity with horizontal. So theta 0 is not 50 degrees, but it is angle with horizontal, means 90 minus 50. So in this case theta 0 is 40 degrees. We know that theta 0 is 40 degrees here. And here water should fall in the basin. But we are asked to find maximum and minimum initial speed so that water falls in the basin. So what does that mean? You can easily visualize here. If speed of water is increased here, then at certain speed water strikes point Q, that is the edge of the basin at Q. And if you go on reducing the speed, then at certain speed that water jet will strike the basin at point P. So we should find that value of U so that water strikes point Q, and that is of course maximum value of initial speed, because if you exceed the value of U, then it will not fall in the basin, it will fall beyond point Q. Similarly, with minimum U, water will strike at point B. If value of U is further reduced, then it will not fall in the basin, it will fall somewhere here. Simple problem it is. You find value of U so that point Q in the path, and find value of U so that point P in the path, and this is how you will get the two values of U for maximum and for minimum value of U. If given and asked are amongst these four parameters, then use equation of path. So we are using here equation of path. Origin is this point. Let's focus on this path first. Point Q in the path. So let's follow the procedure. Choose origin. So origin is here. Write coordinates of points in the path. So Q is point in the path. So x coordinate is 40 centimeters. Take care of unit. So 0.4 meters. And origin is this nozzle end. So below origin point Q is, that's why minus 0.12. If motion starts and ends at the same level, of course not. Check whether equation of path can be used. Yes, coordinates of point Q are given, V0 to be found out, and theta 0 is given, that is 40 degrees. Theta 0 is angle made by initial velocity with horizontal. So put the values here. V0, theta 0, x and y we are going to put in equation of path. So put these values. So y is minus 0.12. Mug up this formula, equation of path expression. It's very important. So put corresponding values. Now listen, here there is only one answer. U squared. Use alpha key and get the answer. Even if it is U squared involved here, there is no other term in which U is. It means it is not ax squared plus bx plus c form. So you will get U squared and then root of U squared, so plus minus. But what is U? It is not velocity, it is magnitude of velocity, which is scalar quantity. So negative answer is a logical answer. So what I mean to say, that is use alpha key, that is type this equation as it is using alpha key, and you will get U. And because at this initial speed point Q is in the path, this is the maximum speed we can allow, 2.707 meters per second. So really speaking, it is one step problem. But here one instruction I am giving you, sometimes to complete the calculations, calculator takes its own time. For these calculations, calculator is going to take much time. You may think that calculator is not working properly, but don't think in that manner. Give calculator its own time, and after some time this answer will flash on your calculator. So we have found out maximum U. Now we want to find minimum value of U. So when U is minimum, point just strikes point P. So case 2, and what is that case? Point P in the path. Point P in the path. What are the coordinates of point P? 0.1 and minus 0.12. Now we want to find initial speed when point P is in the path. So just put these values in equation of path and you will get the answer. Same calculations again. So these are the two values of initial speed. Read this problem. A player throws a ball. Here is a player and he throws the ball. A player throws a ball with initial velocity 24 meters per second from point A. Here is point A. Determine maximum height h. Maximum height h. Remember, height is measured from ground, so there is ground level. Determine maximum height h the ball can strike the wall 30 meters away from the player. So wall is 30 meters away from the player. And the corresponding angle alpha. Listen, this is very important statement. Determine maximum height h. Ball can strike the wall 30 meters away from the player and the corresponding angle alpha. So this maximum height h corresponds to certain angle alpha. So at certain angle alpha, this ball reaches maximum height. Remember this. What is that angle alpha? That is also you are asked to find out. Assume the ball released at height 1.5 meter from the ground. So 1.5 meter above the ground the ball is thrown. Take g 10 meters per second square. So we are going to use value of g 10, not 9.8, because it's special instruction given in the problem, so we should follow it. Procedure of analysis we are following. Choose origin where motion starts. So point A is origin. Write coordinates of points known or given in the path. Coordinates are distances from origin. So origin, check it where it is, and then you write the coordinate. So what is x coordinate of point B? 30, and y coordinate is yb. It is unknown. But you are asked to find h, height. No problem. We will complete calculation, because in equations of motion or in equation of path, y coordinates are involved and not height. If motion starts and ends at the same level, then check whether range and time. No, not at all. Then check whether equation of path can be used. Yes, because watch here. Initial velocity 24, angle alpha. You want to know maximum y coordinate. So given and asked are among these four variables only. Y coordinate to be found out, theta 0 to be found out. Theta 0 in this case is alpha. So y and theta to be found out, initial angle of velocity, and then x is given, v0 is given. So given and asked are amongst these four parameters, then we use equation of path. So we are going to use equation of path. So v0 24 meters per second, theta 0 is alpha, x coordinate is 30, and y coordinate of point B, y coordinate of point where projectile or that ball strikes the wall, that is yb. So put these values in equation of path. Once you get yb, you can add 1.5 meters to for h. So y is yb, theta 0 is alpha, x is 30, and v0 25. I have substituted it. Now check, there are two unknowns here. So how to proceed? So listen, determine maximum height h. You are asked to find maximum height h and corresponding angle alpha. That is what in the problem suggested you to use condition of maxima minima. You want to find maximum. Check here, alpha. If you go on changing values of angle alpha, say alpha is much less, then the ball will strike the wall much below the point shown in the diagram. So at different angle alpha, the point where ball strikes the wall be different. But we want to know maximum y, and this y coordinate of point where ball strikes the wall is function of alpha. Where if you want y be maximum, then dy by d alpha equal to 0, condition of maxima. So we are going to first differentiate this equation with reference to alpha, and then we'll equate it to 0. Now simplify it. So this is how yb is a function of alpha. Then 1 by cos squared alpha is sec squared alpha. So when yb is maximum, dy by d alpha equal to 0. So differentiate equation with reference to alpha. So 30 sec squared alpha, tan alpha differentiation is sec squared alpha. And here it is sec squared alpha. So 2 sec alpha, and then differentiation of sec alpha, that is sec alpha tan alpha. So this is how we are using condition of maximum minima. Now for yb maximum, dy b by d alpha equal to 0. So put dy b by d alpha equal to 0. Sec squared alpha will get cancelled. Divide this expression by sec squared alpha, and therefore you will get tan alpha, and therefore you will get alpha. This is one of the answers. You are asked to find corresponding angle alpha. Remember, this is the alpha, angle alpha, when dy by d alpha equal to 0. That means this is angle alpha when y is maximum. So put this value of alpha in this equation, in earlier equation, say this equation. So I have substituted alpha is equal to 62.96 degrees in this equation, and I got YB maximum. But before you write final answer, don't forget you are asked H. So add 1.5 and then you write the answer. So H max is equal to 23.23 meters. So this is how we have answered the problem. In this lecture, we have solved all problems check using equation of path. The given information and what you are asked in the problem are amongst these four variables v0, theta 0, x and y. In that case, we use equation of path. Remember the procedure of analysis. Don't solve any problem using trial error method. Just follow the procedure. Visualize the motion, and to visualize the motion, draw line diagram of the motion and follow the procedure. Choose origin, write coordinates. If motion starts and ends at the same level, we have not yet solved that type of problem yet, but we'll solve it in another lecture. Check equation of path can be used, and if equation of path is not sufficient, then use equations of motion. This is the right procedure.